Hi, welcome back to another episode of Algebra in Words, the video series on YouTube. We're continuing our discussion on radicals, and this will be the last video in that series. In the last two videos, we looked at imaginary numbers and complex numbers, and in this video, we're going to be looking at what's known as rationalizing the denominator. If you want to follow along with the written instructions for rationalizing the denominator, as well as more examples, you can find that in my book, Algebra in Words 2, and I start that on page 70 in this book. The link to that on Amazon is in the description box below. So first of all, what is rationalizing the denominator? Well, in a previous video where we were dealing with radicals in the denominator, I discussed rationalizing the denominator, which basically means some call it that we like to report answers so there are not radicals in the denominator. So it's manipulating and rearranging a fraction that has a radical in the denominator so that there's no radicals in the denominator. And then some books might also call it a form of dividing a fraction by radicals, or in this case, by imaginary numbers or complex numbers. Now, as we learned in the previous video, and hopefully you are tying this together, that imaginary numbers count as radicals because an imaginary number, I, represents the square root of -1. So the point is, whenever we see from here on out I or a complex number with I in the denominator, we need to manipulate it so that our final answer does not have I or any radical in the denominator. And that's what I'm going to show you how to do in this video. Now the strategies for this are very simple. There's two types you're going to deal with. One type is when you have a binomial complex number in the denominator, like this problem, and like in this problem. And then the other form is when you just have one term with I in the denominator, like in this problem. The methods are basically the same, but a little bit different, and I'll explain the differences and similarities. But in short, the strategy is very simple. All you have to do is determine the conjugate of the binomial of the denominator. The focus is the denominator. Determine the conjugate binomial of that, and multiply the top and bottom of that times that conjugate binomial. I always like to put the denominators in parentheses, so I recommend that you do that, because that'll make the binomials look more like binomials and conjugates. But anyway, let's get right to the point. If we're looking at the binomial 2 minus I, what is the conjugate of that? Well, keep the first and the last term the same, and just change the sign. So since this is 2 minus I, it's going to become 2 plus I. And remember that to rationalize a denominator or convert a fraction, whatever you do to the bottom, do to the top. So since we multiply the bottom by 2 plus I, multiply the top by 2 plus I, the exact same thing. Okay, a quick note before we start is to make sure you follow that exact strategy and not to mix this up. You're not multiplying the top by the conjugate, by its own conjugate, and you're also not multiplying the top and bottom by conjugates of each other. You're starting by the denominator here, determining its conjugate, multiplying its conjugate here and to the top. And basically once you just do the math, that's it. So let's start in the top. And since we have -6 in the top, we're going to be distributing that through the quantity 2 plus I. And I went over distributing with complex numbers in the previous video if you need more help on that. But assuming you know how to do that, -6 times 2 is -12. -6 times I is -6I. Now in the denominator, if you remember when you multiply conjugates, you can do the shortcut. You only need to multiply the first terms together and the last terms together. The product of the outer and the inner will cancel to 0. So product of the first, 2 times 2 is 4. The product of the last, negative I, and this should be I forgot the dot. Negative I times I is negative I squared. And make sure you see this to completion. Anytime from now on that you have an I squared, convert that into negative 1. And that's going to simplify it even more. So convert I squared into negative 1. So in the bottom we're going to have 4 minus negative 1. And that's going to now become 4 minus negative 1, which is 4 plus 1. 4 plus 1 is 5. And although the step I'm going to show you next is not going to much matter here, but it might in other times, in other problems, is notice that there is a greatest common factor in the numerator, and I recommend, and I'm going to do this with you, factoring that out. We have negative 12 minus 6i. Let's factor the greatest common factor of negative 6 out of that. And again, it doesn't matter here because the negative 6 and the 5 in the denominator are not common factors to be canceled out. But in other problems, they might be, and that's why I recommend that you try to factor the greatest common factor in the top if possible. But we can't, and so this is our final answer. Notice that there is now no radical or no I or no complex number in the denominator. It's just one number, and that's exactly what we need it to be. Let's take a look at the next problem. And the next problem is basically much the same as the top one. It's just that in this one, in the numerator, there's two terms, a complex number, whereas in the last problem, there was just one term in the numerator. But the strategy is going to be the same. Let's put these in parentheses, and let's focus on the denominator. Is there a radical in the denominator? Yes, there is in the form of the complex number I. And so we're going to think of the conjugate of 1 minus 4i. And the conjugate is the same first and last term, but just change the sign from negative to positive. 1 plus 4i. And what you do to the bottom, do to the top. And now in the top, we're just going to FOIL it. Product of the first terms, 3 times 1 is 3. Product of the outer, 3 times 4i is going to be 12i. Then the product of the inner terms, negative 2i times 1 is going to be negative 2i. And then the product of the last terms, negative 2i times 4i is going to be negative 8i squared. And we'll combine like terms in the next step. Let's now multiply the bottom. And these are conjugate binomials again, so we're just going to do the shortcut. Product of the first, 1 times 1 is 1. And the product of the last, negative 4i times positive 4i is going to be negative 16i squared. In the top, let's combine the middle terms, which are alike. So we're going to rewrite the 3. 12i minus 2i is going to become 10i. And now, I would normally tell you to convert the I squared into negative 1. And we would do that. Normally I would write that out for you like I did in the previous problem and in the previous video. But now that we know what to expect for that, let's do sort of 2 steps in one. We can do part of it in our head. If we know that I squared becomes negative 1 times negative 8 is going to become positive 8. And let's see the top through to the end. Now that we converted the I squared to negative 1, and then negative 1 times negative I, change the sign of this into negative 8 into positive 8. Now we have like terms, the 3 and the 8, which we can combine to 11, and the top becomes 11 plus 10I. Now let's finish the bottom. And again, we'll sort of do the shortcut for the bottom as well. We have negative 16I squared. And since we know that I squared is negative 1, negative 16 times negative 1 makes it positive 16. So I brought over the 1, I converted this to 16, positive, and now we can add 1 plus 16, which is 17. And that's our final answer. 11 plus 10I over 17. And there's not much else to it than that. Now we're going to look at the last problem. And in the last problem, instead of having two terms or a complex number in the bottom, we just have one instance or one term of I. Now, the strategy for this, I told you they're a little bit different. They are, but they're not. And I'll tell you the shortcut strategy. The strategy is, when you have one term with I, always multiply the top and bottom by the opposite sign of the term than is here originally. Since this is negative I, we're going to multiply it times positive I, or you could just say I. And what you do to the top, what you do to the bottom, also do to the top, so we're going to multiply the top and bottom also by I. Now, for people that are wondering, why is that? Because can't you just do I times I is equal to I squared? Here's the reason for that, and if you can connect these reasons, this is how the reasons are actually the same. It's just that you don't write part of it. Here's what I mean. Let's just off to the side write as if I wrote 0 plus I. Okay, now why might I write 0 plus I? Because if we're writing I as part of a complex number, the real part number could be 0, right? And when it's 0, we usually leave it off, but we could write the 0. So if we consider this as the complex number with positive I, and then I said to you, what is the conjugate of that? You would say it's 0 minus I. So that's the basis behind multiplying whatever singular term of I times its opposite, meaning its opposite sign, if you're wondering where that comes from. So now all we have to do is multiply. Put the top in parentheses so we can distribute the I throughout the conjugate, throughout the binomial complex number. I times 3 is 3I. And I times 2I is 2I squared. We'll simplify that in the next step. But now we also in the bottom have negative I times positive I, and that equals negative I squared. And remember that convert I squared into negative 1, and negative times negative 1 is positive 1. And then if we go back to simplifying the top, 3I times, let's write the 3I, and then where we have 2I squared, let's convert the I squared into negative 1, and then negative 1 times positive 2 makes negative 2. There's no other like terms to combine in the top, so the top is simplified, and there's also no greatest common factor in the top, so we can't factor that out either. And finally, since everything is over 1, we can just as well just chop off, just not write the over 1 part, because we know that anything can be assumed to be written over 1, so we can just write the final answer as 3I minus 2. So there you go. That's how to rationalize a denominator with I in the denominator. Also also called sometimes dividing by complex numbers or dividing by imaginary numbers. And that's all there is to it. So I hope you found this video helpful, and I'll see you in the next video.